All right. So when we start to see these comes, trust me, you're already going to know the answer to this. Now, what happens when that thought comes from the brain, travels down the spinal column, jumps into the muscle, and then we see the neuron plugging into the muscle? What is that space called in between the neuron and the muscle? Neuromuscular junction. Say, hey, I remember that. Yeah. So here you think you're learning all this new information. It's just being put together in this package that makes it a little bit more fun to think about. Now, flip over onto page 91 with me. Now, here's when we start to understand this thing about size principle. Now, all motor neurons are put together in different sizes. What kind of people are you? Okay. Would it make sense to you that the motor neurons in your fingers might be smaller than the motor neurons in your quads? Yes or no? Yes. Because here's the whole thing. Do the motor neurons in your fingers, can just your motor neurons recruit enough to solely just them lift 400 pounds? No. When trained properly, could the motor neurons in your legs be able to lift, squat, press, pull in your hams and your quads 400 pounds? Yes. So there's this thing called the size principle. And it is talked about in the left-hand column of page 91. And what the size principle says, motor neurons are recruited from the smallest to the largest. Now, if you stop and think about this, this makes good sense. So let's just say that I am hopping in the squat rack and I am getting ready to do that 400-pound squat. Am I going to be holding, is the bar going to be touching my hands? Yes. Which is starting with large motor neuron units or small ones? Small ones. So here's what this means. You're going to use motor neurons in the specific order that they are recruited from small to big. On the count of 3, stand up. 1, 2, 3. Okay, sit down, please. Now, on the count of 3, stand up and jump up. 1, 2, 3. Okay, thank you, sit down. Now, do you think, good job, Kendall. Do you think that in the first option or in the second option, you actually recruited more and bigger motor neuron units? The second one, why? You have extra movement. You ask your body to exert more power, which this is wonderful. Now, so here's a question I have. Let's just say I'm coming over here to Nick, and I am going to repeatedly pick up this highlighter, put it down, pick it up, 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 put it down. Am I using large motor neuron units or small? Okay, here's the thing about motor neuron units. They can go and go and go and go and go and go and go. In reality, how long could I probably repeat this action if I really wanted to challenge myself? I probably could keep going with that, keep going with that, keep going with that. So these are little bitty tiny motor neuron units. They are made for quick, rapid movement, okay? When you think about these, you guys think about a machine gun. They can keep going and going and going. It doesn't take time to reload. Now, let's just say that my next challenge that I'm going to give myself is I'm going to walk over, I'm going to have Nick sit on that desk, and all of a sudden, I'm going to walk over with the highlighter, with Nick on it, and I'm all of a sudden going to power clean that desk with Nick sitting on it. One time. So here's the thing. Would I need to use larger motor neuron units to be sure that that happens? Yes. Yes or no? Yes. Yes. So here's what we see. You start off with small and you go to large. But here is what is so amazing. In the right-hand column of page 91, there is this thing called selective recruitment. Now, selective recruitment is this magical thing that your body does, because your body will respond to whatever you ask it to. So whenever you ask your body to do something big, it's going to all of a sudden say, I'm skipping through all these little ones. I'm just going to pretend like you're with me, and I got to go to the big guns. So when you think about big motor neuron units, think about a cannon fire. Because think about when you have to load a cannon, you got to pour the shot in, you got to put the ball in, then what, you got to plunge it down in there, then you light it, and then on the count of 3, make the noise the cannon says. 1, 2, 3.
Boom.
Boom. That was terrible. 1, 2, 3.
Boom.
Okay. But then, here's the question I have for you. Would it take a little bit of time for me to reload that cannon? Yes or no? Yes. So again, kind of like Nick said, I'm going to do it one time, and then what am I going to have to let those motor neurons do? Reload. Before all of a sudden we can make that happen again.
That's the ATP refilling?
That all goes back to the sliding filament theory. Every single bit of this goes back to sliding filament. And it goes back to the calcium, the ATP, the troponin, the tryptomyosin, all of those things. Now it just starts on a bigger level, because that's what fires all this through the nervous system. Excellent question. Excellent question. Now, okay, so size principle tells us that motor neurons are recruited in order to get the job done. Selective recruitment says, we got a big job, so we're bringing in the big guns to make it happen. It's amazing how our body will do that. Do you remember us at one point in time talking about this thing? And it's buried in the text in here, but let's have a learning moment with it. Do you remember when we talked about preloading? Do you remember that word? Okay, that's whenever, let's just say an athlete, let's say I'm gonna all of a sudden do the power clean with Nick again. And all of a sudden, what my brain, remember it all starts with the thought, and then it goes activated down through the body. My brain, in doing this, is all of a sudden preloading to make that happen. So preloading and selective recruitment are really two sides of the same coin. And your body is doing this just because you ask it to. Your body sees something that you need to get picked up, and it sends the message, hey, grab that tumbler. Hey, put that down. And our body can respond to that and make those adjustments. So it's a beautiful thing. Okay, say got it when you got it? All right, if you'll look on page 92, there's that word neuromuscular junction. Say we got it. Nice. Okay, now, here's one of my absolute favorite things. This is called reflex potentiation. Now, I'm going to bet that this is an answer to more of the boys in the room than the girls in the room. How many of you guys, or even girls, I don't want to say that this is not just a chick and a dude thing, okay? How many of you have ever owned a wrist rocket slingshot? Oh, okay. We got them for our boys for Christmas. It's awesome. That might have not been my smartest parenting move when it was used against me, but anyway, that's the way it goes. So when you have a wrist rocket slingshot, okay, it's this thing that fits on your arm, and then all of a sudden you have this rigid band right here. You can put the launching object in there. You pull back. You ready, Darcy? And all of a sudden, I'm going to release it. And what's going to happen to that rock that I had in there? It's going to land where? Right in Darcy's forehead. Now here's what we know. If I all of a sudden were to do that same thing with a little skinny rubber band versus a wrist rocket, which one is going to have more potential to launch that rock farther? The wrist rocket. Now here's what we know. You have this thing called a Myo Tactic Reflex. I'm on the right-hand column of page 92. Now check this out. This harnesses the involuntary. You guys, you can't even think about this. It's involuntary. It is woven, so just think, deep inside you, you have wrist rocket potential instead of just rubber band potential, okay? It's an involuntary elastic property of muscle and connective tissue. This tells me that you were born to jump. What were you born to do? What were you born to do? If you stop jumping, you are going from a wrist rocket to a rubber band. Your body will respond to whatever you ask it to. So if you all of a sudden do this much jumping, that's all you're going to get. Whereas if all of a sudden you do this much jumping, that's what you're going to get. You get to choose.